In the low frequency, the capacitance, all the capacitance, assume low frequency, assume frequency is 0. Capacitance will be open. Okay, so it will offer infinite impedance. Okay, so that is the reason why the gain is slowly increasing. As you increase the frequency, slowly the capacitive reactance will be changing from infinity to a finite value. DC la வந்து the capacitive reactance value is infinity. Xc is equal to 1 by omega c, correct? So at zero frequency, the reactance is infinity. So gain is 0. The gain will start at 0. As the frequency is slowly increased, the gain will increase and it will touch the mid frequency where the gain becomes constant. So at low frequency, the circuit will behave like a high pass filter. So when you have capacitance in series and resistance in shunt, it is called as a high pass circuit, high pass filter. How it is high pass filter na? I will just say you understand. I'll just justify this. Please listen carefully. The capacitive reactance is given by 1 by omega c. So at low frequency, when omega equal to 0, capacitance is infinity. So it will act like an open circuit. So whatever low frequency signal you give, it will not go to the other end because you have an open circuit here. Okay, when you give omega equal to infinity, 1 by infinity is 0, capacitance will behave like a short circuit. So whatever input you give, it will reach your output. So low frequency is completely blocked, high frequency is completely allowed. So this circuit is called as a high pass filter. Remember, for high pass filter, capacitance in series, resistance in shunt. Low pass filter inverse, resistance in series, capacitance in shunt. So this circuit will behave like a high pass filter in the low frequency region, and the gain is given by this formula. Okay, and you have a cutoff frequency FL equal to 1 by 2 pi R1 C1. So this R1 C1 will determine what is the cutoff frequency of my low frequency region. So the point where the gain becomes constant, right? That point is called as the cutoff frequency. And what is the value of cutoff frequency? It is 1 by 2 pi R1 C1. So till this FL, your gain will be slowly increasing. So once it crosses FL, the gain will be constant. So you want to find the region where gain is constant, right? So that is why we define two cutoff frequency, one in the low frequency region called as FL, one in the high frequency region called as FH. So this, whatever we have seen, whatever we are seeing is the low frequency response of your amplifier. So similarly in the high frequency also, and this cutoff frequency is also given one more name called as 3 dB frequency. Because in the cutoff frequency, the gain is going to be 1 by root 2 times the maximum value. So it is 0.707 times the maximum value. So it is called as 3 dB cutoff frequency. If you take logarithm for 1 by root 2, it will come minus 3 dB. So that is why this frequency is called as 3 dB cutoff frequency. Because on the point, the voltage is 1 by root 2 times the maximum value. Maximum value is 1. So 1 by root 2 times 0.707. Okay, so if you take logarithm of 0.707, you get minus 3 dB. So this FL is called as cutoff frequency or 3 dB frequency. Okay, 3 dB frequency, we have 3 dB frequency. One is low frequency, other one is higher frequency, right? So low frequency, whatever 3 dB frequency you have, you call it as lower 3 dB cutoff frequency. And whatever cutoff frequency you have in high frequency, it is called as upper 3 dB cutoff frequency. Differentiate, we are having two different names for the cutoff